So last class we talked about systems of equations, Lindsay and Haley. And what did we find? What is the answer?
The intersection.
It's the intersection of the points on the graph, right? And I showed you how if you plug in x is 2 and y is 3, it works for both equations, okay? So that was linear, okay? Today we're going to transfer over to non-linear. So take a look at this example on the left. It says solve the systems of equations. So first step, solve the equation for y. Done. Step 2, graph in your calculator. So open up your calculator, go to y equals. And now go ahead and type in both of these. So one of them goes into y1, one of them goes into y2. So x squared minus 8x plus 12. And then in the second line, negative 2x squared plus 16x minus 30. Negative 2x squared plus 16x minus 30.
There's two.
And graph. Now, because your calculators were all reset, all of them should be a 10 by 10 graph, so you should all be good. Just to show you guys, first of all, how many answers are we going to have? Two, right? How many times do these parabolas cross each other? Twice. You can kind of see, this is one of our answers, and this is one of our answers, right? But just to review, I want to show you a cool way to zoom. Everyone hit zoom. We haven't done it in a while, but number 1 is zoom box. Hit enter. And it should be flashing at the center. If you move your cursor, remember this is, so kind of get it to a, kind of the top, I like to go to the top left corner. And then when you hit enter, it allows you to drag a box around what you want to zoom into. So, not necessary in this case, but I'm just showing it to remind you that this is always a possibility, especially if you're trying to find an x-intercept. So see how I kind of drug a box around those two intersections, and then hit enter, and it will get you a little bit closer. So now, last class we reviewed a lot of graphing stuff. How do I get to the x-intercepts and the minimum and the maximum? And the second trace. So in this case, which one of those is going to be best for us? Yeah, we're trying to find out where they intersect, right, Colin? Yep. So we're going to hit F5. Now, how many answers do we have? 2. There's 2. So we're going to have to do this process twice. But go ahead, I'm going to do the right one first. So I'm going to move my cursor really close to that intersection. And then hit enter, enter, enter. Now you can see it's a pretty ugly answer. So this might be a multiple choice test. They wouldn't expect you to round that or type that in. But one answer, go ahead and copy that down. Remember, the answer is a point. So about 5.41 comma negative 2. That is the point of intersection. Now find the other one on your own. See if you can go through that process on your own without having any help. You get 2.59.
Yes, sir.
Comma negative 2. So what do you notice about those 2 points? They both have the same y value, right? They're both down 2. So a good question they might ask you, what is the equation of the line that goes through both intersections? It's like a weird way they'll ask this question. What's the equation of the line that goes through both intersections? First of all, is it a vertical line that goes through both? Or is it a horizontal line?
Horizontal. I got you.
Yeah. So you can kind of imagine it. It's right here, right? So what is the equation of this line that my pin is at?
Y equals 2.
Y equals
Negative 2.
Negative
Sorry.
All right, now do the second one. You should be able to do the second one on your own. Find all solutions to that system. So we would add 6 over, so this is actually y equals negative x plus 6. This is already ready to go. So math right gives us absolute value, x minus 2, and then arrow out to the outside plus 1. And then I'm going to go ahead and hit zoom. 6 takes me back to the standard 10 by 10. Just really quick. So how many answers do we have?
1.
There's only one. How do we know? How do we know that these are actually never going to intersect?
Because
Can you
they-
see
Parallel.
Parallel.
Yeah, they're parallel, and we can see that because this has a stretch value of 1, which isn't a stretch value at all, right? It's normal. Up 1 over 1, up 1 over 1, each way. And what is this slope? Yeah, so this is going up 1 over 1 to the left. This one's going down 1 over 1 to the right. You can see that those are never going to intersect. So our only intersection is right there. So second trace, intersect. Just get close to it. If there's only one intersection, your calculator will automatically give you the answer, but it's good to kind of get in the vicinity. How many have got 3.5, 2.5? Awesome.
Nice.
Anyone need help with any of that we just did? All right. So here, this is exactly like your warm-up, basically. It's instead of 2 lines, or the absolute value line, it's a quadratic in a line. So, Cami, what is one solution? -1, 2. Now be careful. But you can see the purple is below the line, and the blue is also below the parabola. So this in here would not be, that is not part of the solution. Use your context clues. You know, like in English class, use the clues around the word to figure out what the definition is.
Sure.
Same thing in math. Kind of look around, see the clues they give you. So what is a solution?
-1, -2.
2, 1. Good. Thank you.
0,
Amy.
0.
2, 1. Joe, what's an answer?
0, 0.
Thank you. Tyler, what's an answer? -4 is 0. Good. That's in the overlapping region. Okay, what is not an answer, Lawson?
0, 7.
Good. Over 0, up 7. Brianna, what is not an answer? -1, 5. Good. Okay, now I'm going to ask you guys, yes or no? Is this an answer?
No.
Is this an answer?
Yes.
Is this an answer?
No.
Is this an answer?
No.
Is this an answer?
No.
Is this an answer?
No. No,
Yes.
it's a dotted line.
No.
But it's on the red.
It's on the solid line, but it's also on the dotted line.
Yes.
So it's no. It is not a solution to both of them, right? What does a dotted line mean?
It's not a solution.
It's not a solution. Okay. Is this?
No.
No. What about here?
Yes.
Yeah, because it's below. See how it's below the dotted line? And it's on the solid line. So yes. What about here?
Yep.
Yes.
What about here?
Yes.
What about here?
Yes.
What about here?
No.
Good.
I cannot be fooled.
Okay, I'm not going to do this because we basically did that for our warm-up today. Okay, let's do this one right here. We're only going to do the one on the left. We need to write a system of equations that creates the triangle. So, first of all, I like to do like a little bracket. How many equations are we going to have?
3.
3. To
Gosh,
make a
mine
triangle,
was
we
at
need
3
3,
sides.
right? So, let's start with
Joe, you're wrong.
this blue one right here. What is the equation of that line? Good. Y.
equals 6.
I'm not going to put equals because it's not an equal
Y
sign.
is greater than 6.
Now look at the blue line. Where's the shaded region? Is it above it or is it below it?
Less than.
It's below it, so a less than sign, and is it dotted or solid? It's dotted, so y is less than 6. Can everyone see that?
Yeah.
But y is less than 6 is all of this, right? So now we need to chop it off. I'm going to erase all this side now. And let's do this line. So this is my y-axis. It's kind of hard to tell. What is the y-intercept of this red line?
4.
4. What is the slope of this line? Rise over run.
One over one.
Up 1 over 1, up 1 over 1. So we call that 1x plus 4.
Y is greater.
And all of them start with y. Now look at the red one. Is the shaded region above the slide or is it below the slide? Above. So we need a greater than sign. And is there an or equal to? No. But greater than red is all of this. Now technically we've already chopped off the top, right? Because we took care of that with the blue line because we're under the blue line. The only thing left, we have to take care of this left side. We need to chop it off right here. So we need to write the equation of that green line right there. And can you see how when you do that, it entraps a triangle? So what is an equation of a vertical line always start with?
X.
Good. X.
Or negative.
Now where does it cross the x-axis? -3. Now this is kind of weird because it's left and right. But we know right is positive and left is negative. So which one, where is it shaded? Is it greater than x or is it less than x? Greater than x. Or equal to. Why is it or equal to?
Because this is all line.
Yeah, that's the only solid one, right? So we just created a system of 3 inequalities that created a triangular shaded region. Good job. See, that wasn't that bad. No, it was not. All right.